Because of energy shortages, transportation and scheduling problems, the stockpiling of larger quantities of materials is needed. If you have a big job to do, this is the machine that can do it. The Fairfield Engineering Company has a working agreement with MAN Corporation of New York and Nuremberg, Germany, to provide the best answer to the growing materials handling problem. In the next few minutes, we'd like to show you this machine and what it can do for you. It can do a better job of moving materials in large volume and with higher reliability than any other equipment on the market. And here's why. It is built better from the ground up because it was designed with these three major design considerations in mind: lower wheel loading, higher machine efficiency, better bucket wheel design. We want to familiarize you with this machine to show you why these design considerations are so important. The entire machine is supported by bogie wheel assemblies. The exact size and number of these wheels is determined by the load to be carried. Next, the equalizers have been built up to support the gantry. You can see one leg of the three legs of the structure here. This top view shows that the gantry forms the base for the slew bearing. This bearing allows the entire upper structure of the machine to rotate. The rotate platform is above the slew bearing and supports the main mast, tie rods, ballast boom, ballast box, stacker boom, operator's cab, and bucket wheel. The stacker boom houses the boom belt, leading from the bucket wheel to the central chute, which feeds the material to the impact table and onto the yard conveyor. These are the main structures of the machine. Now that you've seen the parts, we want to show you how they go together and why they form a machine of superior quality. Let's begin again at the supporting wheels, the bogie wheel assemblies. The size of these assemblies is large enough to meet the load requirements of the machine, yet no single wheel has to support more than 48,000 pounds. This provides high reliability, and because the load is distributed carefully over several assemblies, the result is savings in reballasting costs. Between the bogie wheel assemblies are the motors and gear drives used to move the machine during a traversing action. Positive locking of these wheels in place on the rails is provided by rail clamps, which are spring-loaded for fail-safe action and are released hydraulically. The bogie wheel assemblies are connected to a series of equalizers, shown here on a scale model. You can see how the loads are safely distributed from the machine through the gantry and through several equalizers to the many bogie wheel assemblies. The number and size of the equalizers is dependent on the number of bogie assemblies required to carry the load. These assemblies are equipped with jacking pads so that major downtime is avoided. Any single component can be easily removed and replaced, since the load on any one assembly does not exceed 48,000 pounds. These equalizers are of box beam girder construction, providing high strength and reliability. Connections between moving parts are machined to give smooth fit, low wear, and ease of replacement. Here you can see the pin connection from the equalizers to the gantry. All joints are articulating to allow proper transfer of weight and automatic alignment for any changes in the machine or the rails due to temperature changes or settling of the ballast. On the dual leg side, the major articulating joints allow for changes in rail elevation. The weight is distributed across the three-legged gantry to the single leg side. The equalizing system on the single leg side has a self-limiting ball joint that allows the machine to adjust for any variance in the distance separating the rails and accommodates force variation in the structure in all directions. All of these equalizing systems support the three-legged gantry or base plate upon which the entire weight of the machine rests. The gantry also houses the slew bearing, the largest bearing in the machine, the one that gives the machine the ability to rotate. The bearing is a triple race roller bearing with labyrinth seals. The bearing has inspection plates that can be removed to inspect for wear and allow planning for any replacement months ahead of time. The slew bearing is held in proper orientation to the gantry by means of high tensile bolts passing through it. The slew bearing is also connected to the rotate platform by high torque bolts. The surfaces of the gantry, the slew bearing, and the rotate platform are all machined for precision mounting of these components without the need for fillers. This proper machining allows the working loads imparted by the upper structure and rotate platform to be transferred through the slew bearing to the gantry. The slew bearing is designed to permit a 250% temporary overload. Here is one of the striking design features. The slewing gear teeth that are driven to rotate the machine are not part of the slew bearing. In fact, they're not part of a gear at all. This machine uses pin teeth, and you can appreciate pin replacement over bull gear replacement in a machine of this size. The slew drives are eccentrically pin mounted to the gantry and are reached by walkways on the maintenance platform. This eccentric pin mounting allows the backlash of the machine to be adjusted to practically zero by only one man. Also, the machine is designed to operate on half the number of drives available. The rotate platform provides mounting points for all of the other components and transfers the loads to the slew bearing and supports auxiliary equipment such as hydraulic control rooms and boom conveyor drives. It is at the proper height to perfectly balance the dead weight of the stacker boom and bucket wheel with the ballast boom and ballast box. Regardless of the size of the machine, when it is in a static condition, the machine is in near perfect balance. The lower section of the main mast accommodates the pin connections for the stacker boom and ballast boom and the hydraulic luffing cylinders. The top is machined to accommodate tie rods for stacker boom and ballast boom. The tie rods are made of specially selected steel plates, which are X-ray and sonically tested. The ballast boom and box are structural steel members to accommodate the concrete counterweight, permitting the machine to be properly balanced. The tie rod to the stacker boom is pin connected. Opposite the ballast boom and box is the stacker boom, designed to hold the reversing boom belt conveyor as well as the bucket wheel reclaimer. The stacker boom is of truss-type construction. The operator's cab can be raised and lowered to give the best view under all operating conditions. Here, the cab is up to clear the roadway, while the bucket wheel is brought close to the road. It can be kept low to observe bucket loading, or raised to observe discharge. All the controls for traverse, slewing, and luffing actions are contained in the operator's cab. Here's a view from the cab. Bucket wheels are available in two basic types, cell types and cell-less types. The cell-less type has buckets mounted on the outer surface of the wheel. The backs are closed off by a fixed plate against which material presses until it reaches an opening at the top of the wheel. The material falls from this opening through a loading chute into the load skirts. The cell type has buckets mounted on the outer surface of the rotating wheel, but the backs are open to discharge across the face of a cone. The cell type is preferred because it takes less energy to operate, and the material flows toward the discharge the instant it comes in contact with the bucket. It has excellent discharge, and there is less wear because of its design. The buckets can be disconnected by removing two pins and one wedge lock. The boom belt transfers the material from the bucket wheel to the central chute. This belt has retractable load skirts on both ends to accommodate stacking or reclaiming. This same belt can handle any tonnage from 10,000 tons an hour in the reclaiming mode up to 14,000 tons per hour in the stacking mode. And although the machine has two conveyor drives, again, it can be run with one. The central chute receives material from the boom belt conveyor and directs it to the impact table. The chute is lined with impact plates to reduce maintenance costs. The impact table, consisting of a structural frame and closely spaced heavy-duty impact idlers, receives material from the central chute and loads it onto the yard belt conveyor. Let's see the MAN machine in action. The machine you're watching is a reclaimer. At this particular installation in Canada, there's another reclaimer, a pair of stackers, and other equipment to meet the entire material handling requirements. Here, the loading of the buckets is exactly right for the material being handled. You can see clearly the action of the material within the storage pile after each bucket has made its cut. The operator can traverse the machine in either direction and slew in either direction on both sides of the track and luff up or down as required. Luffing action is extremely accurate and is easily operated to permit the proper depth of cut into the storage pile. The slewing action is very smooth and allows operator flexibility in the handling of the machine. He may operate it by computer, or during peak loads, he can manually crowd the machine to its upper design limits with complete confidence. particular machine was designed for an operating efficiency of 75%. It has actually achieved an operating efficiency of 95% through a planned maintenance program of 8 hours once a week, and kept that record through the first 4 years it was in use. So, if you have a big job to do, keep in mind that the bucket wheel stacker reclaimer from Fairfield Engineering and MAN is years ahead of its time in design and efficiency, but available now to meet your individual needs.